derivative of logarithm, derivative of ln x is 1 over x, and derivative of ln u, chain rule, is u prime over u. So here if you have this one, derivative of ln x, as we said, is 1 over x, so 2 over x. Here it's of the form u times v. Derivative of 2x is 2 times ln x, plus 2x times 1 over x, so you're going to get 2 ln x plus 2. Here this is ln u, so it's u prime over u. Derivative of minus 2x plus 3 is minus 2 over minus 2x plus 3. This is of the form u times v. So this is 2 times ln 5x minus 3. Plus derivative here ln u is u prime over u. So 5 over 5x minus 3 into 2x. This is of the form u over v. Derivative of u prime. So 2x minus 1 over x into x minus derivative of x is 1 into u. So if you expand, so 2x minus 1 minus 2x plus ln x, you're going to get this one. Here it's of the form u over v, so 5 plus 1 over x into ln x. Derivative of ln x down is 1 over x into numerator. So 5 ln x plus ln x over x minus 5 minus ln x over x. Cancel these two, you have this one. And if you're doing the table of variation, certainly here you equate to 0. So ln x equal to 1. So x equal e power 1. You do the table, x here is bigger than 0. You start from 0, e power 1, infinity, f prime, and f. Okay, here the sign. If you pick a number bigger than e, you can see it's positive, negative. You do the limits, decreasing, increasing. Okay, here the same story, equal to 0, so ln x equal to 1, x equal also e power 1. So here in Hospital's rule we know these. Infinity plus infinity is infinity, minus infinity minus infinity minus infinity. Infinity minus infinity put strongest in factor. A number over infinity 0, a number over 0 infinity. You know these. Infinity over infinity or 0 over 0 use 2 Hospital's rule. 0 times infinity, why we do Hospital's rule? Because infinity can be written as 0, a number over 0, so we refer back also to 0 over 0, or a number over infinity 0 times infinity, so this will be infinity over infinity. So 0 times infinity can be reduced to Hospital's rule. Since logarithm is an increasing function, so as x tends to infinity, ln infinity over infinity, and we know that if you have y equal ln x bigger than 0, so if you want to do limit as x tends to 0, so ln 0 can be written as 0.1 power infinity, 0.1 power, and 0.1 times 0.1 times 0.1 times 0.1. So it will be infinity into ln 0.1. So it will be infinity times negative, no, it will be minus infinity. So always limit as x tends to 0 plus of ln x is minus infinity. If you want to understand it in another way, we know that e power infinity 2.71 raised to infinity is infinity, but e power minus infinity is 1 over e infinity. So a number over infinity is 0. So if you want to write vice versa, so minus infinity tends equal, for example, ln 0. We cannot say ln 0 equal minus. Limit as x tends to 0 of ln x is minus infinity. Okay? So these are important for the problems. Let us do the limits here. Limit as x tends to infinity. Infinity times infinity is infinity. Here, Hospital's rule. We do infinity over infinity. Derivative of x is 1. Derivative of ln x is 1 over x. So it's x, which is infinity. Limit as x infinity, come in here, infinity over infinity. Derivative of ln x is 1 over x. Derivative of x is 1, Hospital's rule. So a number over infinity is 0. Here, limit as x tends to 0 plus, you know, because x is bigger than 0 in ln x. So ln 0 is minus infinity over 0 plus. So it's minus infinity formula. Here limit as x tends to 0 plus, so it's 0 plus over minus infinity, so 0, because a number over 0 over infinity is 0. If you have lim as x tends to 0, limit as x tends to 0 plus, lim 0 plus is minus infinity over minus infinity. We do derivative over Hospital's rule, derivative over derivative. So 2 over x over 1 over x, so it is 2. Here it's infinity over infinity. You do Hospital's rule. 2 over x is 1 over 1 over x, it's 2. Limit as x tends to 0, this is 0, minus 2 times minus infinity, then 0 is minus infinity. So this is plus infinity, not minus, so plus infinity. Now, here you have infinity minus infinity, so you put in factor. Always, let me tell you, if this is y equal ex, this is x, this is then x. So a variable is stronger than logarithm. So if you want to put x in factor, the strongest, so you divide each one by x. So here infinity over infinity, we do Hospital's rule only here, because here you have infinity over infinity. Always where you have infinity, even if it's a partial, it's a part, you do on the part Hospital's rule. So it's x times 1. If you do derivative of 2 ln x is 2 over x, derivative of x is 1, a number over infinity is 0, so you have x into 1 minus 0, and limit as x tends to infinity, here it will be infinity. Here you have infinity plus infinity is infinity. Here limit as x tends to 0, you have minus infinity over minus infinity, you do Hospital's rule. So 2 plus 1 over x over 1 over x. If you replace x by 0, also again you have infinity over infinity. We do again Hospital's rule. Derivative of 1 over x is minus 1 over x square. Minus 1 over x square is minus 1 over x square. So it will be 1. Limit as x tends to infinity, here infinity over infinity, Hospital's rule. So 2 plus 1 over x is 1 over 1 over x. A number over infinity 0, 0, in 0 plus. So 2 over 0 plus is a plus infinity. So here you have infinity minus infinity. We put x in factor. You divide each one here by x and by x. Here you have infinity over infinity. You do Hospital's rule, as you can see. A number over infinity is 0. So it is infinity. Here we have 0. We reach 0 times minus infinity. We need to do Hospital's rule. So here you keep x up, ln up, and you take x down 1 over x. So now we apply Hospital's rule. Why? Because here you have minus infinity, and a number over 0 is infinity. So derivative of ln x is 1 over x. Derivative of 1 over x is minus 1 over x squared. So here it will be 1 over x times minus x squared over 1. So you're going to get minus x, and if you replace x by 0, you have 0. Here as x tends to 1, you have 0 and ln 0 plus in x 1 plus here if you want, because x minus 1 bigger than 0, x must be bigger than 1. So 0 times minus infinity, I keep ln up and I take x minus 1, 1 over x minus 1. Always when you have 0 times infinity, if you have logarithm, you keep logarithm up and you take the variable 1 over down. And directly you do Hospital's rule. Derivative of ln u is u prime over u. Derivative of 1 over x minus 1 u prime v minus v prime u over v square. You do it. So you're going to get x minus 1 and the square cancel out. You take this one up. If you replace x by 1 here, you're going to get 0. Now here you have infinity minus infinity, infinity minus infinity over infinity. Up I have infinity minus infinity, I put x in factor. Here I have infinity over infinity, and x cancel out. Here I do Hospital's rule. So it will be 5 over x over derivative of x is 1 minus 1. Only I do here Hospital's rule. I don't touch the minus 1. So a number over infinity is 0. So 0 minus 1 is minus 1. The last one here, you have 5 ln x minus x over x. So here infinity, you have minus infinity minus 0 over 0, minus infinity over 0 plus it's minus infinity. So this is concerning derivative and limits using of logarithm, where we have used Hospital's rule. Thank you.